Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-1 for October-November 2022 for questions 4 to 6. Question 4. A block of mass 8 kilograms is placed on a rough plane which is inclined at an angle of 18 degrees to the horizontal. The block is pulled up the plane by a light string that makes an angle of 26 degrees above a line of greatest slope. The tension in the string is T newtons. The coefficient of friction between the block and the plane is 0.65. Part A. The acceleration of the block is given as 0.2 meters per second squared. Find the value of T. Now, we need to resolve the forces. Close this T here. It will give us a cosine. So I will have here T, then cosine of 26. Okay, then we also have this one here, vertical to the plane, perpendicular to the plane. So we shall have the mg cosine, that is the vertical component of the weight of the block. So that will be 8g, then cosine of 18, and then there will be here mg, m is 8, so 8g, then sine of that 18. Okay, then we shall have mu r here because it is a rough plane, and of course r, we find it here, the normal reaction. The normal reaction is always there for a particle which is on the plane. Okay, then remember we resolved this t here. We have to also open it up here. Okay, so opening is sine and then closing is cosine. So I'll have here t, then sine of 26 degrees. Now, we are going to use, since we don't have the movement vertical or perpendicular to the plane, that means those forces are in equilibrium. So R, when I look at forces vertically, R plus the T sine of 26, then is equal to 8g cos of 18 degrees. So this simply means that R is going to be equal to 80 cos of 18 degrees, then minus T sine of 26 degrees. Then let's look at the forces acting horizontally. And since there is movement here, then that means we are going to use F is equal to MA. So there is a net force that takes the particle up, and that is the T cosine of 26. Then we subtract these two forces opposing the motion. So we have mu, and mu is given as 0.65. You can check for it here. And then our R is this one we have just gotten, 80 cos of 18 minus T sine of 26. Close the brackets. Then we also have mg sine theta, so that will be 80, then sine of 18, which is then equivalent to the mass of the block is 8 times the acceleration, which is given as 0.2. Now I'm going to pull out the terms that have gotten t, and then I factorize it out. So I have t here, cosine of 26. Then when you get this times this one, it is going to be a plus. So plus that 0.65, then it multiplies with the sine of 26 degrees, then times t. Then I can actually take these other terms this way. So 8 times 0.2, that gives us 1.6. And then the other one is going to be, you take this one, this other side, it is going to be a positive. Okay, so plus 80, then sine of 18 degrees. Then when I multiply these ones here, it is a minus. So when it crosses, it becomes a positive. So I will have plus 0.65 times the 80 cosine of 18. Okay, so we can factorize out t is common. So here we shall have cosine of 26 and then plus 0.65 sine of 26 degrees. Okay, Then this one is equal to whatever is this side, 1.6 plus 80, then sine of 18 degrees, then plus the 0.65 times the 80, then cosine of 18. So that therefore implies that our t is now going to be the whole of this 1.6 plus 80 sine of 18, then plus the 0.65 times the 80 cosine of 18. Then we divide everything by the cosine of 26 degrees, then plus the 0.65 sine of 26 degrees. Okay, so what do we get to three significant figures from the calculator? So we have 1.6, then plus 80 sine of 18, then plus, this is 0.65 times 80, then cosine of 18. Then we go down here and we put cosine of 26, then plus 0.65 sine of 26. So what do we get? We get our answer as 64.0 to three significant figures, 64.0 newtons to three significant figures. Part B, the block is initially at rest. Find the distance traveled by the block during the fourth second. Now, when they say during the fourth second, let us look at something here. Okay, maybe 0 here, this is 1, this is 2, this is 3, this is 4. So in between here, this is the fourth second. Okay, fourth second. This is the third second. You see that? This is the second. Then this one is the first second. You see? Now, if we want to get the distance traveled in the fourth second, we shall get the distance traveled in the 4 seconds. Okay? I can let that to be S4. And then I subtract off the distance traveled in the 3 seconds. Okay? I can call that S3. Okay? If you love watching games, especially football, you find that if, let's say, somebody scores a goal when 20 minutes have gone, but then they say maybe 20 minutes and you see some seconds, like let's say 25 seconds. Okay, when they are recording the goal, they put 21 with that one. So it means that the goal was scored in the 21st minute. The 20 minutes have already gone. So now we are moving into the 21st. So that is what it means. Now, here we are now going to use our S, which is equal to UT plus a half AT squared. So if T is equal to 3, so what will be the S3? The particle was starting from rest, right? So we have 0, then plus, this is going to be a half, times the acceleration is given as 0.2, now times the 3 squared, okay? So 0.1 times 9, because this one, this 2 cancels with this one, then you get 0.1, so times 9, you will get 0.9 meters. How about when t is equal to 4 seconds? So S of 4 is going to be equal to 0, then plus a half. The acceleration is still 0.2, and then the time here is 4, then we square it. So 16 times 0.1, that one will give us 1.6 meters. So this means that the distance traveled, in the fourth second is going to be equal to 1.6, then minus the 0.9. And this one gives us 0.7 meters, as simple as that. Question 5, a particle P moves on a x-axis from the origin with an initial velocity of negative 20 meters per second. The acceleration a meters per second squared at t seconds after leaving O is given by a is equal to 12 minus 2t. We are given an expression here for acceleration. That means this topic is under variable acceleration. And when we are using variable acceleration, we use differentiation, and integration. We don't use the other equations of motion. The v is equal to u plus at, the s is equal to ut plus a half at squared, and v squared is equal to u squared plus 2as, because when we use those ones, that means acceleration is constant. Here, acceleration is varying, okay? So we strictly use integration and differentiation. They are saying sketch a velocity time graph for t ranging from 0 to 12, indicating the times when p is at rest. Okay, now when p is at rest, that means here v is equal to 0. So we need to find the expression for the velocity. We know that acceleration is equal to the rate of change of velocity. So meaning if I want to get velocity from the acceleration, then I will integrate the expression for acceleration with respect to t. So when we integrate 12 minus 2t with respect to t, we shall get here 12t, then minus 2t squared over 2, that one will give us t squared, then plus c, because we don't know the constant that disappeared when they differentiated. So you have to put an arbitrary constant. Now at t is equal to 0, velocity was given as negative 20. It is here initially negative 20. So that means when I substitute here, this is 0, this is 0, and this is 0. I mean, the v is negative 20. That means our c is going to be equal to that negative and negative 20. So therefore, v, the expression for velocity, is going to be negative t squared plus 12t. Let me write it in decreasing powers of t, then minus 20. Okay. Now, we need to find the times when v is 0. Okay. So for v is equal to 0, we shall get this negative t squared plus 12t minus 20 is equal to 0. I can multiply everywhere by negative 1. That means I can get t squared minus 12t, then plus 20, which is equal to 0. And then when I factorize this one, two numbers, when I multiply them, they give me 20. That one is going to be 10 and 2. When I add them, they give me negative 12. That means these two numbers are negative. So I have t minus 2 and then t minus 10. Remember, you have to show the examiner how you have solved the quadratic equation. So our t is equal to 2 and then our t is equal to 10. These are the times when the velocity is 0. And this is very important when we are finding the displacement or the distance. Actually, when we are finding distance, because if some part is below the t-axis, and when you integrate right away from the start to the end, and there is a part which is below the t-axis, it is going to subtract from the positive part, and then you get a wrong answer. So it is very important to find these times where the velocity is constant, such that you can be in position to put modular signs on those parts that are below the t-axis to make them positive, because area cannot be taken as a negative. Okay. Now, having found those times, this expression for v here is for the quadratic equation, and the coefficient of t squared here is a negative. So because the coefficient of t squared is a negative, this one is going to be an N-shaped curve. Okay, so if it is an N-shaped curve, then it has a maximum point. Okay, and for maximum velocity, what are we having? Maximum velocity, then dvdt, which is actually our acceleration, is equal to 0. So I will get the 12 minus the 2t is equal to 0. Automatically here t will give us 6. Okay, so at t is equal to 6, then what is v? Okay? Then we can substitute in here negative, then 6 squared minus plus 12 times 6, then minus 20. Okay, so minus 36 plus 72, that one will give us 36, then 36 minus 20, then this one gives us 16. So v is 16 meters per second when t is equal to 6. Okay, now since they told us, we have found here the times when the v is 0. what is the value of v when t is 12, because we have to consider up to there. Okay, so for v, I mean for t which is equal to 12, what is the value of v? Substitute here negative of 12 squared, then plus 12 times 12. Automatically this is 144 and this is negative 144, so those ones will go. Then minus 20, so that means v is equal to negative what? 20. Now these are the ones that I'm going to need when I'm sketching my graph here. So let's go down and we sketch. I'm going to put my axes here. You draw a reasonable graph here, can have this, and then here I'm going to have the velocity, which is in meters per second. This will be 0. Then here we shall have time in seconds. Okay, so I can have here 2, maybe 2, this is 4, then 6, then 8, then 10, then 12, like that. And let's say this is the negative 20. Okay, so we saw that when t is 6, that is when we are having the maximum height, I mean the maximum velocity, which corresponds to 16. Now when I'm drawing, I'll draw this n-shaped, then it passes through 2, and then it comes here and curves off from there here, and then passes through the by the way, this one for 12 here also corresponds to this one of negative 20. So then I proceed and then put this one here. I don't go beyond that because they told me from 0 to 12. Okay, so that is going to be our curve. By the way, where this curve cuts the t-axis and this one here, the turning point is always in the middle of those x values. So if you get 2 plus the 10, you get 12. Divide by 2. Do you see that you get the 6? Okay, so that is that. Next, find the total distance traveled by p in the interval 0 to 12. You see, we have to get, when you sketch, even if they haven't told you to sketch, it is very important that you do a sketch such that you know the parts which are below the t-axis. So right from our sketch here, this one here is below the t-axis. So I don't, even this one, so I don't integrate from 0 then to 12. No, I have to integrate from 0 to 2, then I put that in the modulus because this one gives a negative answer. Then the one that is above here, that one I don't need to put in the modulus because it is already above the t-axis. And then this one here, I also put it in the modulus signs to make it positive. Okay, all right, now we can go back, and you know that velocity, okay, velocity is equal to the rate of change of displacement. So meaning displacement is going to be the integral of v dt. You see that? Now let us find displacement. We are going to integrate the expression for the velocity. The expression for the velocity, we got it as what was it? The expression for velocity is here, negative t squared plus 12t minus 20. So let's go back. We integrate negative t squared plus 12t minus the 20 with respect to t. Increase the power by 1, divide by the new power. This will be negative t power 3 over 3 minus 12t squared over 2. That will be 6. Okay, t squared. Okay, this is a plus. Then minus 20t. Okay, I don't need to put a c because I'm going to put this one. I'm going to have the limits. Okay, now that means total distance traveled. Remember, total distance traveled is the total area under the graph. Total distance traveled is equal to total area under the graph. Okay, so we are already integrating the expression for v. Now, all I'm going to do, okay, let me first write it here. I'm going to integrate from 0 to 2, but we have seen that it is below the t-axis, so I'm going to put the modular signs, okay? Then the t squared minus 12, it is a plus here, it is a minus 20 with respect to t. Then the next one, we are integrating from 2 to 10, and we are putting negative t squared plus 12t, then minus the 20 with respect to t. And then we shall also put the modular signs when we integrate from 10 to 12, this expression t squared minus t squared plus 12t minus 20 with respect to t, put it in modulus. Then we can now have the integral here. Already we have gotten its negative t cubed over 3 plus 6t squared minus 20 of t. So let's put the limits, modulus. Then also here we are going to have negative t cubed over 3 plus 6t squared minus the 20 of t. We are having 10, then 2 here, then plus the modulus of, this is negative t cubed over 3 plus 6t squared minus 20 of t. And we are putting 12 here, 10 here, then in the modulus. So we are going to put negative 2 cubed over 3, then plus 6 times 2 squared minus 20 times 2. Of course, we shall subtract 0, okay? Because this is 0 when it goes wherever there is t, it just goes. Then plus, put 10. So negative 10 cubed over 3 minus, plus 6. Then we shall have 10 squared, then minus 20 times 10. Then subtract, let us put 2. This is negative 2 cubed over 3. Then plus 6, 2 squared minus 20 times 2, like that. Then we can put on another one here, the last one, plus we are having 12 cubed over 3 with a negative here, plus 6 times 12 squared minus 20 times the 12, and then subtract. Then this other one here, remember it is in the modulus. This is negative 10 cubed over 3 plus 6 times 10, then squared, then minus 20 times 10, okay, like that, then in the modulus. So what we get, let us put all of these in the calculator. So the first one, we have negative 2 cubed is 8, so 2, then power 3, and then this one is over 3, then plus 6, and then 2, then squared, minus 20, then times 2. So this one gives me negative, you see, the answer is a negative, so negative 56 over 3. In the modulus, it will become a plus. Then plus here, of course, we are going to have minus, but then we have gotten this as negative 56 over 3. You get? For this one here. Now, how about this one for the first one? So where there is 10, where there is 2, I'm going to put 10. Then I also come to this one, I put 10. I also go to this other one here, I put 10. So I get 200 over 3. So this is 200 over 3. And then I come to this other one here. You can see that again, this one here for 10 is the one that I've put, okay? So I will just say here that minus, it is 200 over 3. Now, how about this one when we put 12? So where there is 10, I'm going to put 12. I come here and I also put 12. Then also this other one here, we put 12. So this is 48. So we have 48 here. And of course, when you subtract these ones, you are going to get a negative value here. Okay. So that negative value automatically will turn it to be a positive. Okay, we have modulus signs here. Now, here we shall get the 56 over 3. Okay, then here, this one is going to be a plus. So it will be 256 over 3. And then 48 minus this 200 over 3. It gives us negative 56 over 3. But with the modulus, it becomes a plus. So plus 56 over 3. So all of this together is actually over 3. So 56 plus 56, then plus 256. So 56 plus 56 plus 256. This one gives us 368. So we shall write 368 over 3. So it is to 3 significant figures. I can write the answer as 123. 123 meters. That is to 3 significant figures, or you can even leave it here like this. No problem, you get all the marks. Question 6, figure 6.1 shows particles A and B of masses 4 kilograms and 3 kilograms respectively attached to the ends of a light inextensible string that passes over a small smooth pulley. The pulley is fixed at the top of a plane which is inclined at an angle of 30 degrees to the horizontal. A hangs freely below the pulley and B is on an inclined plane. The string is taut and the section of the string between B and the pulley is parallel to the line of greatest slope of the plane. Part 8 is given that the plane is rough. That means there is frictional force, mu r, okay? And the particles are in limiting equilibrium. To be in limiting equilibrium, that means they are on the verge of moving, okay? And on the look of things, when you see these particles of ours here, A is heavier than B. So meaning A is expected to move down, okay? So we have the weight here, which is 4G, and then there is tension which is generated in the string. The same tension here is going away from B. And then the horizontal component of the weight of this B here, because we have the 3G here, is going to be the mg sine theta. And then here we are going to have the mg cos theta. So we shall have 3G cos of 30 degrees. And then here we shall have the normal reaction R. This is 3G sine of 30 degrees. Now, we are now supposed to find the coefficient of friction between B and the plane. Okay, between B and the plane, because it's a rough. And since the system is in equilibrium, that means the, let me first put this one here. This one is expected to be accelerating this way. Okay, so we are going to have these horizontal forces equated and also these vertical forces equated for A. Here R is equal to this because we don't have the motion perpendicular to, we don't have the motion which is perpendicular to the plane. Okay, so now let's begin with A. So with A, we have tension which is equal to 4G. And of course, this one is going to be 40 newtons. Then when we go to B, our R vertically, R is going to be equal to 3G cosine of 30 degrees. 3G is 10, then cosine of 30 is root 3 over 2. That means 30 divided by 2, that is 15. So I can write this as 15 root 3 newtons. Then from there, these ones here, the tension going up, so horizontally, the tension is now equal to the mu r. There is mu r here, by the way, the frictional force. Since this one is expected to be moving up, then that means that the frictional force acts downwards, okay, to oppose the motion. So I'm going to have the T which is going this way is equal to these two forces that are opposing, okay? So we have mu r, then plus the mg sine of 30 degrees. And we are looking for the value of mu. So the tension, remember, is 40. Then I'm going to subtract this one here, which is 30. And then sine of 30, you know, it is a half. And then that will be equal to mu. and then our r is 15 root of 3. So what will then be our mu? So our mu is going to be, this is 15, so 40 minus 15, that one gives us 25. Then we shall divide by 15 root of 3. And this one can give us 25 divided by 15 root of 3. So it is 5 root of 3 over 9. Or to three significant figures, this one can be 0.962. Okay, 0.962 to three significant figures. Part B, it is given instead that the plane is smooth. That means the frictional force goes, and the particles are released from rest when the difference in the vertical heights of the particles is 1 meter. Okay, use an energy method. So here they are specific. Remember, we can also use F is equal to ma, then after we use the v squared is equal to u squared plus 2as. Okay, we use this one maybe to help us find the acceleration, and then after we substitute it here, then to get what we are looking for, the speed of that particle. But now we are going to use the energy method. Now I'm going to consider this particle is up here. Maybe it is going to come up to here. Okay, maybe the particle is going to come up to here. Actually, let me try to put it a little bit up here. So that means it has gone down a certain distance. Let's say the distance is x, it has moved down. Okay, then I'm going to put this horizontal line here. Remember, it is parallel to this one, so that means using the principle of parallel lines, this one will also be 30 degrees. Now, that means also P has come up to here. I mean B has come up to here. It has risen up to here, X, okay, X meters up there. So it goes up X, then A goes down X, okay? All right, now meaning that this distance here, this one here, is going to be equal to, we have a right angled triangle, by the way, here. This right angled triangle here, I'll have the 30 here. Let me remove this one from here. This one that I had put. So that is the one I have. Now, this point here and this one, they are going to be my reference points for the movement of A. Okay, here and then here. Now, when we are starting here, because there is this vertical height generated, particle A is going to have potential energy there. Okay, and then when it comes down to this place here, it is going to have kinetic energy because it will be moving with a certain speed. So since this one is my point of reference, then potential energy is not going to be there. Okay, then for P, I'm also using this point here of reference and also this one here. You see? Now, at first here, remember, the particles are released from rest. So that means they don't have potential energy because it is dependent on speed. And also, there is no potential energy here because this is the reference point, so there is no distance that has been moved vertically, okay? But now, when B comes to this position here, then that means we are going to have the potential energy generated because of this vertical height, okay? Then we shall also have kinetic energy because the system will be moving at a certain speed, okay? Now, using a right angled triangle, okay, in fact, let me just draw it like the way this one is. We have a right angled triangle here. This is 30. Then here we have this distance here, the h, which we don't know, but this is x. So that means I can have sine of 30 is equal to the opposite over hypotenuse. Okay, so when we cross multiply, it means that that h is equal to x, then sine of 30 degrees. Now, I can put x sine of 30 degrees here. Now, I can come to my diagram here. Okay, the other forces that are acting on these particles, do we need them? We don't need them, okay, because we are using the energy method. Now, the distance moved by x, okay, distance moved by B up the plane is equal to the distance, okay, moved by A downwards. Okay, now, and we also know that this one here, what I've written here is actually for this. I have X here and then I have X here. Okay, now if this is 1 meter here, we have this distance X and then this one here. That means when I add them, I get that one. So I will have X plus the X sine 30. Then this one will be equal to 1. Sine 30 is a half. So we shall have X over 2 here, which is equal to 1. 1 plus 0.5, you get 1.5, which is the same as 3 over 2 of X, which is equal to 1. So meaning our X is going to be equal to 2 over 3. Okay? Now, using the energy method, we say that work done by the driving force, by the driving force, let me, work done by the driving force minus work done against resistance is always equal to the change in mechanical energy. Is always equal to the change in mechanical energy. Now, work done by the driving force, we are not going to have work done by the driving force because we don't have, these particles are just released from rest and they are falling freely. Okay, so work done by the driving force or the applied force, it is not there. Then work done against resistance, since we are having this plane here is smooth, then that means there is no resistance force. Okay, they said it here that the plane is now smooth, so there is no resistance to the motion. That means work done against resistance is 0. And then change in mechanical energy, okay, is equal to potential energy then plus the kinetic energy. Now we get the final mechanical energy plus the initial mechanical energy. So final, I can have here A will be having, this is the final position of A, it will be having kinetic energy. The final position of B is here, it will be having potential energy and kinetic energy. Okay, so I'm going to write here the kinetic energy for A, it is a half, then times the mass of A. The mass of A is 4. Okay, the mass of A is 4, then times the velocity, which we don't know. Okay, because kinetic energy is a half mv squared, then plus the kinetic energy for B, it is a half, times what is the mass for B? The mass for B is 3, so times 3, then B squared, then plus the potential energy for A. Remember, potential energy is mgh. I mean, that is for B. Okay, B is having potential energy here, which is mgh, and the h for this movement here is x over 2. Okay, it is x out of 2. So we shall get, because sine of 30 is a half, now we shall get m, which is 3, times this is 3, then times the g, which is 10, times h, which is x over 2. You see that? Then minus the initial mechanical energy. It is here when A is having the potential energy, but here B doesn't have any, because I told you this is the reference point, so there is no potential energy, and the system was released from rest, so therefore there is also no kinetic energy. Now we are going to find potential energy for A. So this simply implies that we are going to have the mgh, the h is x. So m for A is 4, so m is 4, then g is 10, and then the h is x, which h, I mean that h, the x is 2 over 3. Okay, now we have 0 here. We can simplify this one here, so we can have 4 here plus 3, you get 7, then over 2. Okay, so we shall have 7 over 2 of v squared. Then this one here is going to be 40 times 2, that is 80. How about here? This 2 will cancel with this, okay, and then this 3 will cancel with this one here. So that means this whole thing gives us a 10. Okay, it gives us a 10. So we are going to have here plus 10, then minus 4 times 10, 40 times 2, 80. So minus 80 over 3. Then I can take these ones this side. What is negative becomes a positive, and then what is a positive becomes a negative. So we shall have 80 over 3, then minus the 10, then this one is equal to 7 over 2 v squared. So this one simplified, I can say 3 times 10, that is 30, and then 80 minus that 30, we get 50. So this will be 50 over 3, then which is equal to 7 over 2 v squared. So when I cross multiply, v is going to be the square root of, first get the 50, multiply it by 2, then you divide by the 3 times the 7. So what is our v? Square root of 100, then divide by 21. And the answer becomes 2.18, that is to 3 significant figures, 2.18 meters per second. And that is that. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and subscribe. See you in the next videos.